All right, we should be recording now. Let's go to this one and share this screen with you. And I've still got my pad over here. I can work out some examples with you as we go along. Now, is there any one of these that you guys would like for me to work first, or shall I just go to the top and work our way through? Not hearing anything. Let's go to the top and work our way through. Number one says, what mass of carbon is contained in 1 milliliter of 0.125 molar Fe3 FeCN6 taken twice? So I want 1 milliliter of 0.125 molar Fe4, left bracket, Fe, left parenthesis, Cn, right parenthesis, 6, close bracket, 2. Okay, and we want the mass of carbon. Okay, let's switch over now so I can, let's see, can I change the camera up? Yes, I should be able to do it right here. Let's go to the, well, it didn't seem to happen. Let's try again. Oh yeah, I clicked the wrong one on this camera. Okay. Well, I don't, oh, I've got to stop the sharing. Okay, now that makes it big enough for you to see. And the problem we're working is what mass of carbon is contained in 1 milliliter of some molar solution. The relationship is volume times molarity is equal to moles. So we want 1 milliliter of that molar. So the if I have 1 milliliter is 1 times 10 to the minus third liters, and I'm multiplying that by the molarity is 0.125. That's going to be in moles of the compound per liter. And set up this way, the volumes are going to cancel, and I'll have moles of compound. But it wanted to know the grams of carbon. So what I'm going to do is add a conversion factor to convert from moles of compound to grams of carbon. Okay, now, looking at this formula, there's 2 times 6 times 1, that's 12 moles of carbon. And the molar mass of carbon is 12.01. So if I'm looking at this, I should have the math all set up ready to do the problem. So if I do, I'm doing my calculator now, 1 with an exponent of -3 times 0.125. That's going to give me the moles of compound. Then I'm going to multiply that by 12 and multiply that by the atomic weight of carbon is 12.01. And if I do that, I come out with 0.08015 grams of carbon. And if we switch back, we can check to see if that's the correct answer. And you should see it. Yes, there we go. So any of you have any questions about that? Remember now, the way we're solving problems is we look at the problem and we try to identify what the problem is asking for. And in this case, it's asking for grams of carbon. We look at the data we're given volume and molarity. So we need to look at the problem, analyze the problem, and then get the relationships we need. Well, we know volume times molarity in moles, volume in liters times molarity in moles per liter is going to give me moles of the compound. And then I have to convert from moles of the compound to grams of carbon to solve that problem. So that's going to work pretty good. That's okay. And the only way I can change that is just change the compound and change the volume and molarity. So if you understand how we did this one, understanding it, not just memorizing, take this times this and times this and divide by this and that kind of stuff, that never works. But the method that we just did by analyzing the problem, filling in the relationships that we know, and solving for what we need, that will work. Okay, I went down too far. Let's go to number 2. What's the molarity of this solution? So let's see, I need to get this off. And now you should be able to see my work pad. And I'll push this up out of the way and we'll start with number 2 then. Number 2, what is the molarity? Let's see, I need to shrink this one down a little bit for me. Won't change anything on your screen, I think. Okay, what's the molarity of a solution of chloric acid that has 82.9% chloric acid and has a density of 1.50 grams per milliliter? So we want the molarity of the solution. Anytime it says what is the molarity, I'm solving for that. I should write down number of moles of the compound. In this case, it's chloric acid. Divided by number of liters of solution. So anytime I'm trying to divide something out, if I can possibly do it, I want to get a 1 in the denominator. And remember, molarity is just a ratio of 2 numbers, this number divided by this number. So the molarity of a drop or a liter or a gallon or a quart is always going to be the same. It doesn't really matter because we're taking the number of moles and dividing by the number of liters of the solution. So I'm going to try to make that one liter. So if I have 1 liter of that solution, well, let's look at what we've got. Okay, the solution is 1.45 grams per milliliter. So 1 liter is going to be 1,000 milliliters. And now I'm going to convert from milliliters to grams of the solution. Okay, well, the density is 1.45 grams per 1 milliliter. So when I do this, I'm going to come out with 1,000 times 1.45 is 1,450 grams of the solution. Now that's not the number that goes in my numerator. I want moles of chloric acid. So I've got to go from grams of solution to grams of the chloric acid. I can do that using the percentage because I know 100 grams of the solution would have 82.9 grams of the chloric acid. All right, so I want to multiply by 82.9 and divide by 100. So I've got 1450 and I want to multiply by 82.9. 2.9 and divide by 1450. Okay. No, I'm sorry. I've got to divide by 100. Okay, that looks like right on my screen. So let's go ahead and do that. So I have 1202.05 grams of the chloric acid. Okay, now I've got to go ahead and bite the bullet. What's chloric acid? It's from chlorate ion. Chlorate is ClO3 minus. Chloric acid is HClO3. All right, so we've got that many grams of chloric acid. Now, to get my number up here, I want the number of moles. So I've got to take this mass and divide by the formula weight. It's got 1 hydrogen. It's got 1 chlorine, 35.45. And it's got 3 oxygens, 3 times 16. So now if I take the number I have on my screen and divide by that formula weight, so I'm just going to do a divide with a left parenthesis, 1.008 plus 35.45 plus 3 times 16 and close my parenthesis. Now that should give me the number of moles that I've got up there. So the number of moles I have is 14. So the number of moles is 14.232 and a whole bunch of other digits. And if we go back to our share screen, then you can look again and we'll see if that's what we got. And there you go, 14.2 molar is the correct answer. So let's look then at the next problem we need is number 3. And number 3 is a reaction. It's got 3 C3H8, that's propane by the way, and 20 H2CrO4, that would be chromic acid. It's going to make 9 carbon monoxides, 10 chromium 3 oxides, Cr2O3, and 32 waters. The molecular weights are given below each one in the equation. And the problem is asking us what mass of chromium 3 oxide, will form by reacting 0.155 grams of propane with 5 milliliters of 3.75 chromic acid. Pull that up so that you can see my screen. And my reaction now, it's saying I'm going to react propane and the chromic acid. The propane is 3C3H8. And I'm reacting that with 20 H2CrO4. And I'm going to only worry about the other thing in the problem is the 10 Cr2O3. Okay, now we want to know what mass of the chromium 3 oxide. So I'm going to put a question mark with grams over the 10 Cr2O3s. We'll react with 0.155 grams of propane. Now the equation is showing 3 moles, and that's 3, and the molar mass given under the propane is 44.1 grams. So I've got this many grams of propane, the equation is showing this many grams of propane. All right, now the next one is volume and molarity. So I'm going to write 5 times 10 to the minus 3. That's liters. It's 5 milliliters. If I multiply that by 3.75, now what I've got in the numerator is now moles. The equation is showing 20 moles. Now the problem said how many grams over here. The equation is showing 10 moles, and the molar mass given in the problem is 152 grams. Okay, now the way I've got this set up, I could actually read the problem off just looking from the setup. How many grams of chromium 3 oxide, Cr2O3, will form by reacting 0.155 grams of propane and 5 milliliters of 3.75 molar chromic acid. And now, if I look at my setup, I have essentially my rebalancing factors right here. There's one of them. 1.155 divided by 3 and divided by 44.1 is going to be one of my rebalancing factors. So all I got to do is do this division that's showing right there. To get the other rebalancing factor, all I have to do is do this division that's showing over here in the equation. So let's do those, and I'll copy the numbers I get off my calculator. 0.155 divided by 3 and divided by 44.1. This first rebalancing factor is 0.0011715, a whole bunch of other digits, but I'm not going to lose any of them. Now I'm going to go over and do this rebalancing factor. It's 5 with an exponent of minus 3 times 3.75. And I want to divide that by 20. And if I do this, I get 9.375 times 10 to the minus 4. Now, this is times 10 to the minus 3, so this is going to be the excess reagent, and this one's going to be the limiting reagent, because we picked the one with the smallest rebalancing factor. Now, my answer is always, that's going to always be equal to the rebalancing factor that's appropriate, multiplied by what you have under the question mark over here. And what you have under the question mark is 10 times 152 grams. Now, since I've still got my rebalancing factor on my calculator screen, the only thing I need to do is say times 10 times 152. So times 10 times 152, I get 1.425 grams of Cr2O3. Now, if we go back and I need to share my screen with you again so we can see the answer to see if we were successful. Here's the problem, and look, there's the answer, 1.42. So that's the way we would do that stoichiometry problem. And we got another stoichiometry problem. This one's going to be number 4. So what it says, as you can read with me, it's the same reaction and the same data is given, but this time we want to know what volume of 3.25 chromic acid is required to make 1 gram of that compound. chromium 3 oxide. Okay, let's go over here so you can see my work pad again. And we'll set this one up. Now, this one said what volume of the chromic acid. So the only two things involved in this problem is the 20 H2 Cr2 CrO4. No 2 there, I'm sorry. Okay, and we're going to make 10 Cr2O3. Okay, now it said what volume of some molarity. What it's really asking me for is how many moles of this would that be? Because volume times molarity is equal to moles. So that's going to be the setup. I want 1 gram of this product. Now the equation is showing 20 moles over here. And the equation is showing 10 times 152 grams over here. Now again, I've got a rebalancing factor. If I just imagine going through right there, there's the numerator and there's the denominator of my rebalancing factor. So my RBF, balancing factor, is going to be 1 divided by 10 and divided by 152. I want to show you a quick trick here. My answer in moles is going to be the rebalancing factor, 1 divided by 10 and divided by 152, and then multiplied by what's under the question mark, 20 moles. Now, this way I'm not tempted to go ahead and divide out that rebalancing factor and get a number and then write it down somewhere and copy it back into my calculator. Remember, I'm trying to get you to learn to work problems as quickly as possible without making mistakes. So all I have to do to get this answer is take 20 divided by 10 and divide by 152. So 1 times 20, 20 divided by 10 and divided by 152. Now, what I'm coming out with is the number of moles of the chromic acid is going to be equal to 0.1315 and some much of other digits. That's going to be how many moles. Now that's got to equal to the volume times the molarity. Now, what are we given in the problem? If I go back to number 4, the volume is what we're trying to calculate. We want to know what is that volume, but the molarity is given at 3.24. I'm sorry, 3.25. So to solve for V, I'm just going to divide both sides by 3.25. So the volume now in liters is going to be the 0.13157 that I've got on my screen divided by 3.25. So divide by 3.25. My answer is 0.00408 and a whole bunch of other digits. And that's going to be in liters. If I want milliliters, it's going to be 4.04 milliliters. 4.048 and a whole bunch of other digits after that. So if we share screen and let you look back at our answer, we get a chance to see if we've got it correct or not. So yeah, there it is, 4.05 milliliters is what we're going to have. Now we've got another equation to do, and this time is also a solution stoichiometry problem. After all, that is what we're supposed to be doing in this unit. So it's solution stoichiometry. And it says what volume of 3.25 molar chromic acid is required to make 1 liter of CO2 gas. So we're going to do solution stoichiometry and we're going to do gas stoichiometry. So now let's go back where you can see my pad again. Now, remember when we're doing solution stoichiometry, the equation we need is volume times molarity is number of moles. When we're doing ideal gases, PV is equal to nRT. So PV divided by R and T will equal number of moles. And the balanced equation is always a statement in number of moles. So now let's look at the data again up here. We want to know what volume of chromic acid. So the equation is involving chromic acid. That's 20 H2CrO4. And volume times molarity. So the first thing I'm going to solve for is moles. Because if I know what goes here and I know the molarity is given, it was at 3.25 molar, then I can solve for the volume. So this is in moles. The equation is showing 20 moles. Now, we're going to make CO2 gas, and there's 9 CO2 gases involved in the reaction. And it wants to know, I want to make 1 liter of CO2 at 25 degrees and 735 torr. So I can get number of moles here by doing PV equals nRT. All right, let's do pressure. Pressure was 735 divided by 760. Remember, we have to get into atmospheres. 760. That's pressure multiplied by the volume. The volume I want is 1 liter. That is in the appropriate unit. I want to divide that by R, 0.0821. And I want to divide that by the temperature. The temperature is 25 plus 273. So that's going to be, the temperature is going to be 298 Kelvin. Okay, so 735 times 1 divided by 760 divided by 0.0821 and divided by 298 is going to be the number of moles. The equation is showing 9 moles. So let's do this math and we'll have a rebalancing factor calculated. So it's 735 divided by 760 and divided by 0.0821 and divided by 298. Okay, and what I'm coming out with is the number of moles is going to be 0.03952 and a whole bunch of digits. So I'm going to write my rebalancing factor. The rebalancing factor is actually the answer that's on my screen divided by 9. So I take this answer that's on my screen and just do divide by 9. Divide by 9. And what I come out with is the rebalancing factor is equal to 0.004392 and a whole bunch of other digits. My answer in moles is going to be the rebalancing factor. I'll say answer again because that's what's on my screen. And I got to multiply by what's under the question mark up here was 20 moles. Okay, so I multiply that answer by 20. And what I come out with is I've got the number of moles is going to be 2.196 and a whole bunch of digits times 10 to the minus 4. And that's equal to the volume, which we don't know, and the molarity we do know, 3.25. So if I take this answer that's on my screen, divided by 3.25, then I'll solve for V. So the volume is going to be equal to the answer on my screen again, divided by 3.25. Divide that by 3.25. And I'm coming out with a pretty small number. I think I've made a mistake somewhere. Yeah, I'm coming out with something that makes no sense. I'm getting 6.76 times 10 negative fifth. Okay, at this stage, it's back up and punt. So let's see what we did wrong. All right. We wanted to know what volume of the chromic acid. The equation is showing 20 chromic acid. So I think that's right. I think that's right. And so I need a 20 down here. That's right. The equation is showing 9 moles of CO2. So I got to get the number of moles. I took pressure times volume divided by R and T. The pressure was 735 torr. Yes. Divided by 760. So that should be right. 0.0821 and 298. That should be set up right. Okay. So, and that should be the number. It looks like the setup is right. So I made a math mistake somewhere. Let's just trace them all back. 735 divided by 760. And then divide that by 0.0821 and divide that by 298. And I'm getting 0.03952. I got the same number, didn't I? Okay, that's the number of moles. I take the number of moles and divide by 9. So I take my answer, divide by 9. I get 0.00434. That's correct. Then I need to multiply that by 20. And that gives me the number of moles of the chromic acid. I think that's probably where the mistake was. Yes, that's not what I got. So I made the mistake right there. It's 0.0874, and I divide that by 3.29, by 3.25, I'm sorry. And I get 0.02, and this comes out to be 0.027028, and some other digits of liters. If I want milliliters, it'll be right there, 27.028, and other digits, milliliters. And now if we go back and share screen, we can check our answer and see if this is coming out okay. Yep, there it is. 27.0 is the correct answer. Now, let's do number 6 now. And see what we have for that. For number 6, we've got a mixture that contains 5 moles of nitrogen gas and 8 moles of oxygen gas. Pressure is 760. What's the partial pressure of the nitrogen in the mixture? Well, no, that's a Raoult's law. So let's get back over here so you can see my screen again. On my work pad, brother. There we go. And you've got a good view of the work pad. Now, we've got 5 moles of nitrogen. Nitrogen is N2 gas. And we've got with that 8 moles of O2 gas. And we want to know, the total pressure is given at 760 torr. And we want to know what is the pressure due to the O2 in that mixture. Well, that's Raoult's law. The pressure due to O2 is going to be equal to the mole fraction of O2 multiplied by P total. Okay, we already know what that is, so let's get the mole fraction of oxygen. The mole fraction of O2, any gas, is the number of moles of that gas, of O2, divided by the total number of moles. In this case, it's going to be the number of moles of O2 plus the number of moles of N2. Well, O2 is 5. I'm sorry, O2 is 8. O2 is 8. And N2 is 5. So the mole fraction of O2 is going to be 8 divided by 13. The pressure of the O2 is going to be the mole fraction, 8 divided by 13, multiplied by the total pressure is 760. So let's do the math and see what we get. So it's 8 times 760 divided by 13. And that's coming out to be what did I do? Oh, you know what? I calculated the partial pressure of oxygen. The problem actually said, what's the partial pressure of nitrogen? Well, that's all is not lost. Pressure of nitrogen is just going to be the difference between what we got here and 760 that we started out with. So all I got to do is take this number I got here is 46. This one came out to be 467.69, and 760 minus that number would be this one. So it doesn't matter which one we did first. So let's just take 760 minus the answer I've got, and that gives us the 292.307 and other digits. Torr is the nitrogen value. So we check back over here. Let's see, I need to start sharing to do that. And there's our correct answer. And by the way, there's the one we calculated. Watch out. No, it's down pretty close to the one down below it. So you want to be real careful. Now, number 7 is the van der Waals equation problem. Now, that's kind of a tough problem in terms of the math. So you want to be very careful. It says use the van der Waals equation to calculate the pressure exerted by 24.5 grams of ammonia. Here are the constants for ammonia. A is 4.3044 and B is 0.037847. It's confined in a 2.15 liter container at 300 degrees Celsius. And we're now to do the calculation. So let's look at the pad. It's number 7. And now this is van der Waals. Equation. Now, this is a toughie. You're going to have to memorize it for this quiz. I'll give it to you on the final if we need it, but on each unit exam, you have to learn formulas and constants. The equation is P plus A n squared over V squared. Look back at your derivation if you want to. V minus NB equals nRT. You know, ideal is PV equals nRT. Well, there's a correction term that's the square of the concentration, N over V. And the A constant is an additive term to the pressure. The volume, we have to reduce the volume of the container by the volume that's occupied by the molecules. And the B constant is the volume of 1 mole of molecules, and N is the number of moles. So this is the van der Waals equation. Now, I want to show you from the equation, if I'm going to ask you to do a calculation, I can ask you to do T. That's pretty easy. If you plug in all these numbers and divide by NR, you can get T. I can also ask you for the pressure because I can put all of these values in and do all the math involved here and get the pressure. I can't ask you for the volume. So don't try to learn how to do that if it's volume, because it's a cubic equation and it's fairly difficult algebra just to get the equation in a form you can use it. So this one is asking for calculate the pressure. So I need to get the pressure on one side by itself. I'm going to divide both sides by V minus NB. So when I do that, I would get P plus AN squared over V squared would be equal to nRT divided by V minus NB. Okay, now I want to get pressure by itself, so I need to subtract AN squared over V squared from both sides. So P is going to be this term we just wrote down, nRT, divided by the quantity, V minus NB. And that's equal, minus, subtract off, minus AN squared over V squared. So now this is the form of the van der Waals equation we need for this particular problem. Now let's look at the constants. We've got the A value is 4.3044. The B constant is 0.03747. The volume V is 2.15 liters. And the number of moles, well, the number of moles is 24.5 grams divided by the molar mass of ammonia. That's NH3. So it's got 1 nitrogen, 14.01, and it's got 3 hydrogens, and hydrogen is 1.008. Okay, so there is my, let's see, what do I want? The temperature is 300 degrees. Temperature is 300 degrees Celsius plus 273, 273.15. I want to be precise. So here's what I'm going to do. I'm going to do this calculation right here. That's pretty easy. If I add 300 to this, I'm going to get temperature is 573.15 kelvins. So that's my temperature. So I've got all of my data in here, except I haven't done this calculation. I'm going to do it in a minute. So here are my data. Now I'm going to do this calculation that's shown right here. I'm going to take N times R. I'll put it down here. R is equal to 0.0821 liter atmospheres per mole per Kelvin. So now I've got all my data right here in front of me. I'm going to just plug this data in that equation. So I'm going to start by calculating N. The reason why I'm going to do that, that'll be on my calculator screen, and I'm going to need it in a couple of places. I'm going to need it right there, and I'm going to need it squared right there, and I need it right there. Now, once I do this calculation, it's going to be in my answer. So let's do it. It's 24.5 divided by a left parenthesis 14.01 plus 3 times 1.008, close my parentheses. Now it's critical I get this right. All right, it looks like I have. Now what I came out with, in case we need to refer back to this is 1.438 and a bunch of other digits, moles. Okay. Now, for me, this is answer on my calculator. Okay, so here's what I'm going to do. I need my answer. So I'm going to take times 0.0821, that's R, times the temperature is 573 times 573, what did I say, 0.15? I did that. Now I've got that numerator done. I want to divide by what's in the denominator, and I'm going to do it just the way it shows on my screen. So I want to do a divide by a left parenthesis, and now I want to put V. The volume is 2.15 minus the answer, second answer, times B. Times B is 0.037847, and now I need to close my parenthesis. And now I want to subtract. Minus A is 4.3044, 4.3044 times my answer squared, second answer squared, and divide that by volume, 2.15 squared, 2.15 squared. Now, if I haven't screwed up somewhere, when I push equal, I ought to get the answer. So let's try and see what I did. Okay, what I came out with is the pressure is 30.370 atmospheres. Now we need a conversion factor, and there's 101.3 kPa per atmosphere, kilopascals. And so I take this answer and I multiply it by, so times 101.3. And now that gives me the number of kilopascals. So I've got 3076.529 kPa. So kilo is 1,000. So I multiply that by 1,000. And I get 3. Let's see, 1, 2, 3, 4, 5, 6. 3.076 times 10 to the 6 pascals. Okay, well, it's not terribly satisfactory, but I get 3.07, and oh, I don't like the looks of that at all. Okay. There's got to be a mistake that I made somewhere up here. I could have entered some numbers incorrectly. So, you know, I think rather than go back and find this error, we'll just go ahead and stop here. I know the setup is correct. I know that we solved this correctly. I know the procedure is correct. Somewhere in the line, I probably transposed a couple of digits. I do that all the time. And most of the time we'd be all right. But the trouble we've got here is we've got two answers that are reasonably close to what I got, 3.23 and 3.19 times 10 to the 6. So we got 3.08 essentially. So we're closest to this number, but I'm sorry, you can't see what I'm doing. It's closest to this answer, but the key says it's this answer. And I've worked this enough times that I'm pretty confident this is correct. So I'll go back off the air and I will work this through again. If it is incorrect and B is the correct answer, then I will upload the correction to D2L and notify you by email that that's what I've done. Okay, so we are really out of time right now. So we'll end this meeting. I will put the video up on D2L. We didn't get time to start the next unit, but that's okay. We'll start it after the quiz on Wednesday. Okay, everybody good? I see I've lost a few people already, but we're right now on time to end. So I'll end the meeting now. You all have a good night and a good day tomorrow, and stay healthy. I'll see you on Wednesday.